Hey, welcome back to the stream. I'm Blake Green. I'm a cloud architect and AWS community builder. Today is part 2 of the Serverless Stack guide. In the first part, we sort of went through the fundamentals of, going through what serverless is, the introduction, setting up our account and the serverless framework and application. We actually deployed a really simple application as well to AWS Lambda. And then, so today's part 2, and it looks like we're going to be diving into creating more AWS resources and sort of building off of what we did in the first part. So with that being said, let's go ahead and dive back in and continue to build out our serverless application. So it looks like we're going to start with creating a DynamoDB table. So we're gonna build a REST API for our Notes app. It's a CRUD, so create, read, update, and delete application or API. Meaning that we'll be performing these operations on our database. So we also want our users to be able to upload files as attachments to their notes. So in this section, we'll be creating a couple of AWS resources, a database, and a file storage service. Let's first start by thinking about how the data is going to be stored. So we're going to use DynamoDB to do this. Okay, so about DynamoDB. DynamoDB is a fully managed NoSQL database that provides fast and predictable performance with seamless scalability. DynamoDB is also a serverless database, which means, as you guessed, it'll scale automatically and you only pay for what you use. Similar to other databases, DynamoDB stores data in tables. Each table contains multiple items, and each item is composed of one or more attributes. We're going to cover some of the basics in the following chapters, but feel free. But to get a better feel for it, here's a guide on DynamoDB. So it gives you a link here. Where does this go to? Oh, nice. So it actually links you to like another sort of guide, it looks like, to, oh, this is really nice. So dynamodbguide.com. I'll try to remember to leave that in the comments below. But wow, this is really nice. Like, I'm not as familiar with databases in general, and I know from a high level, Dynamo is a key value or document database, but it looks like it goes into a bit of advanced topics there, which is really cool and interesting. So that looks like a great resource to learn more about DynamoDB. So nice. But we'll keep continuing on, not try to get too sidetracked, so we can get through some of this guide here. But it's interesting. So it looks like we're going to go into the AWS console now and create a table manually, which I guess is a good thing, right? Like if you're barely learning how to use these AWS services, it makes more sense to go into the console and sort of poke around there rather than trying to figure out how to write it, in a serverless framework application, right? Okay, so let me go back up to the top here. I was just kind of trying to peek forward a little bit to get an idea. Let me get logged into my account. It's like I always just like assumed that we would be writing like serverless framework, code or whatever, and I never actually like log into my account, which I feel like is a good thing, right? Like I think it's a pretty good habit is to like avoid logging into the console, the AWS console, as much as possible. But anyways, okay, so I'm in my AWS console now. Let's see, I'm in Oregon. I don't know if we deployed our first app into Virginia. Let's just stick with Virginia, North Virginia, US East 1. And I'll go into, I'll search for DynamoDB here. Okay. All right. So I think it's because since I have like pre-existing tables in this account, it doesn't like give me that nice little getting started page. But if I click on tables here, and then let's see what I'll try to put this side to side actually. And we'll put this one side to side here. So we can hit create table at the top there. We give it a table name, so notes. And then we give it so primary key and partition key are the same name as, sort key is the same there. Okay, sorry. Yeah, I meant partition key is the same as primary key. So here we're going to add user ID. And then we're going to add a sort key as well called note ID. So your AWS console might look a little different than the screenshots in the guide, but that's okay because they're just constantly updating the guide or the console. Okay, so we're gonna use default settings. Well, yeah. First of all, let's talk about what a partition key and a sort key is. Each DynamoDB table has a primary key, or partition key, which cannot be changed once set. The primary key uniquely identifies each item in the table, so you cannot so that no two items can have the same key. DynamoDB supports two different kinds of primary keys: partition key, so partition key only, or partition key and sort key, or another word is called composite, I guess. We're going to use the composite primary key, which gives us additional flexibility when querying the data. For example, if you provide only the value for user ID, DynamoDB will retrieve all the notes by that user. Or you could provide a value for user ID and a value for note ID to retrieve a particular note. And that's like for better performance, right? So if we only have to query for, a specific user ID and note ID, it's more likely that it'll be a better performance in retrieving that data for us, right? And so they link you to another nice little guide or resource here for understanding how to work with indexes in DynamoDB. So that looks let's see what this looks like real quick. Yeah, so I guess it just links you to the AWS docs. Who reads the AWS docs, right? I mean, come on. This was a good find when they sent us to the dynamodbguide.com. That was good, but to link us to the AWS docs, come on, man, come on. Anyways, okay, so we have our composite key or composite primary key with the sort key. So user ID and note ID. Okay. We're just going to use the default settings. That includes, the read-write capacity, secondary index, key management for encryption at rest. So pretty good default settings out of the box, right? But like I said, if you were to tweak or turn the knobs on the performance of DynamoDB, this is probably where you would change that, because right now the read and write capacity are only set to 5 units each. Okay, so let's see here. I think we're good. Like I said, our AWS console is more up to date than the screenshots that are in the guide. But we can just probably go ahead and continue on. It explains, like on-demand capacity is Dynamo's pay-per-request mode. For workloads that are not predictable, or if you're just starting out, this ends up being a lot cheaper than the provision capacity mode. If the on-demand capacity option is missing and there's an info box containing the message, you do not have the required role to enable auto scaling by default. Okay, so maybe if we hit this customize, let's see what we get. Okay, so rather than using default settings, so forget everything I just said. If you hit customize settings here, you can see that now we're able to use that on-demand feature instead. And this allows us to scale down to 0, it seems, and we can save a few pennies, I guess. So anyways, okay, so we'll hit create table. The notes table is now created. You can find it. Okay, yeah. So we see that here. I think it's still like preparing or provisioning. It's also a good idea to set backups for your DynamoDB table, especially if you're planning to use it in production, which, we're always in production. Come on, let's go. Anyways, okay, now we're going to look at how to store the files that our users upload. All right, so now we have our database table ready. Let's get things set up for handling file uploads. We need to handle file uploads because each note can have an upload file as an attachment. So we're going to use AWS S3, which provides service through web services interfaces like REST. You can store any object in S3, including images, videos, files, etc. Objects are organized into buckets and identified within each bucket by a unique user-assigned key. So in this chapter, we're gonna create an S3 bucket, which can be used to store users' uploaded files from our Notes app. So again, we'll just like we did with Dynamo, we'll just go to S3. And we'll create a bucket. Okay, so the bucket has to be unique. So let's see. They've already used notes app upload. I guess we'll just try to do that. So we'll say notes dash app and then upload. We'll say Blake Green. Just to make it, hopefully that's globally unique. We'll see. Okay, so it looks like we just kind of accept all the defaults here. And we'll hit create bucket. So now we should have a DynamoDB table and an S3 bucket. But now before we start working on our serverless API backend, let's get a quick sense of how all the resources fit together. I'll go full screen here. And we'll say, so now we're going to review our app architecture. So far we've deployed a simple hello world API. We've created a DynamoDB database. We've created an S3 bucket for file uploads. Now we're ready to start our backend API, but let's get a quick sense of how the aforementioned pieces fit together. So here's a diagram of how we were interacting with our API, or the Hello World API, which I think we can. Did I just click out of that? Oh no. Yeah, if we go over to Lambda. Let's make sure that this still works. See, details, right? Cool. Yeah. So here's our little Hello World API, right? So this is us sending a request to our API gateway on the hello route, and the Lambda function is returning this message to us with to our request. So let's see. Yeah, and it kind of just goes through and explains that how we send that get request to our hello route, and the Lambda function returns that message. So the notes, I'll go back to full screen here. The notes app API architecture. So now we're going to add DynamoDB table, the DynamoDB table and S3 to the mix, and we'll be adding a few other Lambda functions, which is interesting because I think you can create like an S3 bucket and DynamoDB table with the serverless framework. So it's kind of interesting why the guide decided to go through and create those resources through the console versus trying to create it through the serverless framework. But I digress. Anyway, so now we can see how the architecture is going to evolve. We'll have this S3 bucket over here for uploads, but now we're going to probably end up tying together, our web service here, our serverless API, with the API gateway, Lambda functions, and DynamoDB. Good deal. So there's a couple things to note here. Our database is not exposed publicly and is only invoked by our Lambda functions. But our users will be uploading files directly to S3 that we created. The second point is something that is different from a lot of traditional server-based architectures. We're typically used to uploading the files to our server and then moving them to a file server. But here we're directly uploading it to S3. We'll look into this in more detail. Yeah, I mean, that's a pretty good call out, right? Like, it is a different way of thinking about your architecture. So I agree. Okay, but yeah, we'll be setting it up such that only our authenticated users will be allowed to access these resources. So that's good too. We don't want random people uploading stuff to our S3 bucket. Okay, nice. We get to finally write some code. So let's get started on our backend by first adding our API to create the note. This API will take the note object as an input and store it in the database with a new ID. The note object will contain the content field and an attachment field, the URL of the uploaded file. Okay. Nice. Okay, so let me go back over to our code editor and we'll go this way with that. We'll go that way. All right. So here we have hopefully that is big enough of a font for everybody. Okay. Never hurts to bump it up one, right? So, okay, so we're in our handler.js file. This is our simple hello world function or API, right? But now it looks like we want to go and create a new file called create.js. So we'll go back in here, add a new file, call it create.js. And I believe in the last stream, we've already imported or did the npm install for the UUID package for module, right? So from and the AWS SDK. All right, so now we're going to create a DynamoDB, a new instance of that. DynamoDB document client, right? And then we're going to create a function, async function main event context. So we're going to say json.parse the event body, right? Okay. And then const params equals an object called table name. And then we're going to get the table name from an environment variable, process.env.table name, which I don't think we've created that yet, but we will. And then an item with a user ID, which has to be a string, right? Because that's the primary key that we added to our DynamoDB table when we created it, if you remember. And then our secondary key was note ID. And for this, we're going to add a unique identifier with v1, I guess. Okay, we could just call the UUID there. And then content will be data. Okay, from the event body that we're parsing. So content, can't spell today. And then we need an attachment, which is data.attachment. Created at, and we're going to give it a timestamp. Date.now. Okay, so that looks good. All the commas. My prettier extension doesn't seem to be working, but usually, like when I hit save, it will add all of the missing commas and semicolons for me, but all right. So then now it looks like we add at the bottom of our file here, we're going to create a try catch block. So first of all, we're going to try and then await the DynamoDB.put and then put the params and make it promise. Oops. Get rid of this guy here. Okay, and then we'll return status code. Oops. Status code of 200, if that works. And then we'll say the body is JSON.stringify. Get this out of here. Freaking VS Code. Okay, and then params dot item. Okay. Or catch error, and then return status code of 500. But we also want to say JSON dot stringify. We want to include the error message, right? Cool. Oh wait, was that supposed to go inside of the? It is. My bad. So this try catch block is supposed to go inside the function. That's my fault. Yeah. There we go. It kind of looks like it's not within that, but anyways. Okay. So let's see what it says here. there are some helpful comments in the code. Okay. Basically in the params section, but the AWS SDK assumes that the region based on the current region of the Lambda function. So if your DynamoDB table is in a different region, make sure. Okay. Let's see here. Parse the input from the event body. This represents the HTTP request body. It contains the contents of the node as a string, right? So we kind of went through that as well. It also contains an attachment if one exists, if the file name of the file has been uploaded to our S3 bucket. We're sort of putting the cart before the horse here a little bit, right? Because we're modeling what our data should look like. And I think that's what will make it easier when you go to write the Lambda function as well, right? So if we model our database or how the data will be put into Dynamo, it just makes it easier to write the Lambda function eventually. So. Okay, so configure the API endpoint. Now let's define the API endpoint of the function. So we go back into our serverless.yaml file, which already includes or still includes our hello world function there. It looks like we keep everything the same. We have the same plugins. We're using the same provider. But now we can go ahead and uncomment the environment section of our provider. And we need to include, I'm just going to delete this here. We'll just include table name. And we'll say notes. Because that's the name of our the DynamoDB table that we created, right? And we need to add, we also need to add IAM permissions so that our Lambda can, interact with our DynamoDB table, including all of these actions basically. So the scan, query, get item, put item, update item, delete item, describe table. So I'm actually just going to copy and paste this because that would be, whoops. Alrighty. So now we've added the environment variable for our table. We've given our Lambda function the IAM permissions to interact with that. Looks like we can actually, we can probably end up just removing our old function here or modifying this. So we can rename this to create. And then we'll call this, our handler is now called create.main. It's still it's going to be a post on the notes path. Okay. So here we're adding our newly added create function to the configuration. We specify that it handles post requests at the notes endpoint. This pattern of using a single Lambda function to respond to a single HTTP event is very much like the microservices architecture. So we would basically, so we have this method for post, right? But if we created like an update, it would also be its own Lambda function as well. I think that's what they're trying to say. The environment, this block allows us to define environment variables for our Lambda function. These are made available under the process.env Node.js variable. In our specific case, we are using the process.env table name to access the name of the DynamoDB table. So like I mentioned before. The IAM role statements is basically, like I've mentioned before, it's just telling us or telling our Lambda function that it does have the permissions to perform these actions on our DynamoDB table. Yeah, this is actually a good call out too, right? So if you're not using US East 1, make sure that you update this ARN endpoint if you're using a different region. Okay, so now we can test our new API. This is cool. I haven't done this before. So to be able to test it on our local, test it locally, we're going to mock the input parameters. Okay, so let's open up a terminal session here. And it sounds like we're going to create a new directory called mocks. And then let's see. So we created a new directory called mocks. We'll create a new file in here called create-event.json. And now we will just add this data to here. Right. And so basically we're just putting in the data that we've written in our parameters, right? Or items that we need to include. So content is hello world, attachment is hello.jpg. The body here corresponds to the event.body that we reference in our function. So here, okay, so yeah, this should parse it and then put it down into here, into content and attachment, right? Okay. Okay, so now, and to invoke our function, we're going to run the following in our root directory. So we can say SLS invoke local -- function create, and then the path of our new directory called mocks, and then create-event.json. I'm not sure what just happened. Oh, shoot. I don't have my, I don't think I've authenticated. I don't have my CLI configured. So let me try to do that. Oh, there it goes. Okay. Oh, did I? So maybe it was supposed to go outside of the function. Okay, so let's look at it's saying that it had an unexpected keyword here. So maybe I was wrong. It's not supposed to go inside of the probably just some punctuation issue. See, that's why I like to use like prettier when it saves yeah. So this should be a semicolon. All right, let's try that again. I'm not good with punctuation, so um, we'll see. So missing semicolon, trailing spaces. All right. Dang it. Okay, so let's look at that again. Or let me see if I can figure out how to start my prettier formatting. So Control Shift P, right? Command Shift P. Oh, that's not right. Okay. I'm all over the place here. All right, let's just see if we can figure out what it's mad about here. So we have our params here. Okay. Then we have our try. Oh, we didn't do semicolon here. If I get another error message, I promise I'll just copy and paste it from the. I like to try to write it out myself. I feel like I learn better that way, but I also don't want to hold up anything any longer. So it looks like we don't need a semicolon there. All right, maybe that's good enough now. What do you guys think? Should we give it another try? All right, let's try it. Let's see here. So we got rid of one. It says no trailing spaces. Trailing spaces are not allowed. Does this include the line? Is that the? I don't know if that's. I honestly don't know if that is what it's referring to. I wish it would tell us like more specifically, but is there trailing lines? I can't even tell. Or trailing spaces. I don't know. This is crazy. Very touchy, you know? Ah, there we go. Well, that's better. We didn't get a trailing spaces error, but we did get a 500. So that means it actually, tried to invoke our Lambda function. So, live troubleshooting. It's good times. But sometimes I wish it was more interesting than just punctuation or trailing spaces. It's going to be my new band name, I think, maybe trailing spaces. Someone's probably already thought of that. But okay, so let's see if that was like expected. I don't think so. Okay, so if you have multiple profiles, you'll need to be okay. We just have my default profile. So it says we should have gotten a 200, a status code of 200, but we got 500, and it says one or more parameter values were invalid, missing the key user ID in the item. So I must have done something wrong. But that doesn't so that doesn't missing the key user ID in the item. Oh, wait a minute. Wait, okay. So let me look back at our serverless.yaml file actually. Did I do another typo? Oh, I know what happened. Okay. So in our DynamoDB table, darn it. So if we go back to our DynamoDB table, and it was a typo on my end. Where's Dynamo? So I think what happened was I named the partition key or the primary key. So if I go into notes. So in the notes, this is probably what happened. In the partition key, I didn't capitalize the I in. Yeah, I didn't capitalize these I's, right? So if we go back over to here, it's saying like we're missing this user ID without the capital I. And if we go back over to our create function, I'm specifying this as a capital I. So I wonder, like, just for shits and gigs, so I don't have to like recreate DynamoDB table, if I just make this a lowercase I for user ID and note ID, and then I rerun this guy. I bet we get a 200. Yeah. So now you can see we were able to get a status code of 200. And now I bet if we, so before we didn't have any items in our table here, but if I refresh, I'm assuming that our new, yeah, here's our new entry with our hello.jpg and the contents of hello world. And here's our timestamp and the unique identifier for the note ID. So that was my bad. Hopefully you didn't, or hopefully you caught that and fixed it. I might have to go back and fix it. Okay, so now it looks like we're going to refactor our code. So before we move on to the next chapter, let's quickly refactor the code since it's going to be doing much of the same for all of our APIs. So start by replacing our create.js with the following. Okay, yeah, so this code doesn't work yet, but it shows what we'll want to accomplish. So yeah, I think it's basically just saying like we're gonna reorganize this a little bit and make it a little cleaner, I guess. So import handler from, I'm assuming we'll create a libs directory, and handler, not hangler. Okay. Oh, and we don't want to import Hanley. Man, just typos all over the board today. Dynamo DB from libs. I can never spell DynamoDB. Okay. So for our, okay, so we're going to make this like our main entry point. So we're going to say export const main equals, and then this will be handler. Okay, and then we're making this an async. Async int. Yeah. Cool. Okay. So let me save that. And then we still have, we are parsing the event body. We have the parameters still. And then looks like we are going to get rid of this tribe catch block. Yep. Yeah, so we get rid of this. Let me exit out of that. Okay, so then we'll just say await dynamo db dot put params. And then we need to return params dot item. And of course, don't forget the semicolon at the end, right? So, okay, so that looks good. We want to make sure our Lambda function async and simply return the results. We want to simplify how we make calls to DynamoDB. We don't want to have to create a new instance of Dynamo every time, right? So we want to, and we also want to centrally handle any errors in our Lambda function. Finally, since all of our Lambda functions will be handling API endpoints, we'll need to handle our HTTP responses in one place. So we'll go ahead and create that libs directory that we mentioned here. So create a new folder called libs. And then here we're going to add our DynamoDB lib. DynamoDB-lib.js. Okay, and then here we're going to import the SDK from AWS SDK. Client, and then we create our instance of new AWS.dynamo. And then we'll export default get. Just gonna get put query update delete. Right. So we want to say params, pass in the params, and that's client.get params .promise. And then I'm just gonna go ahead and copy and paste this. So params, but we need to change this to put, right? And then this to query. God, get out of here. Query. And then this to update. And finally, delete. Cool. All right. So here we're creating a convenience object that exposes the DynamoDB client methods, and that we're going to need in this guide. Good deal. Okay. So now we're going to create a new file called handler-lib.js. Man, I keep calling it Hangler. The D is not even close to the G on the keyboard, but it's kind of funny. All right, so here we are going to say export default function handler lambda. Return async function event context. Let body and status code. All right, you get another try block here to run the Lambda. So body equals await Lambda, the event and context. Status code equals 200. Catch the error. Body equals error e dot message. Status code equals 500. Okay. Finally, it looks like we return whatever status code we get, right? With the body JSON dot string fi the body. Okay. So we need to not forget our semicolons. Let's go over this in detail. So we are creating a handler function that will use as a wrapper around our Lambda functions. It takes our Lambda function as an argument. We then run the Lambda function in a try catch block. On success, we JSON stringify the results and return a 200 status code. If there's an error, we return the error message and the 500 status code. It's important to note that the handler lib.js needs to be imported before we import anything else. This is because we'll be adding some error handling to it later, so that it needs to be initialized when Lambda function is first invoked. So now it looks like we can also remove our handler.js file. Oh, this was just the hello world. So we can delete that. All right, so next we're going to the common issues, response code. Let me go full screen here. So if you see a status code of 500, when you invoke your function, here's how to debug it. Oh, okay. So you can just console log out the error message. But anyways, okay. So I think we're running on about an hour into the stream. I think that's going to be all for today. We didn't get as far as I would have liked, but live troubleshooting and debugging is it's always a fun or a little bit time consuming at times. So I think that's where we'll stop for now, and then we'll pick it up again and continue to build out our serverless API. It looks like looking forward a little bit, we're just going to continue to add the other operations to our API, including like the get, list, update, delete, and then finally deploying it. So maybe in the next one, we'll kind of go through it a little quicker, because now I feel like we have the foundation for continuing to build this out. Especially after refactoring, right? Should be a little bit easier to copy pasta a little bit. But I think that's where I'm going to stop for today, and then we'll pick it up later. So thanks for watching, and I'll see you next time.